Hello, welcome to Madam YY channel. Today we are going to look at the chapter 4, aromatic compounds. So at the end of the session, you need to learn how to identify the aromatic compounds based on the 4 criteria, which are cyclic, planar, complete conjugated, and also the aromatic compound will obey the Huckel's rule. So aromatic compound, okay, also known as ARENE. So this is an organic compound which contain at least one benzene ring or other ring structure that resemble benzene in its chemical properties. So in the picture, this is a shape of a benzene ring which is in hexagon. So there are 4 criteria for aromaticity. So the molecule must be in cyclic, which is it must be in a ring structure, planar, complete conjugated, and also the number of pi electrons must be satisfy the Huckel's rule, which we will use Cn plus 2. So first criteria, the molecule must be cyclic. So you can see this is a benzene structure. A cyclic means they are in a ring. And then for the second structure, okay, the ring is not complete, so it's not considered as cyclic. So acyclic is not a aromatic compound. And then the second criteria, the molecule must be planar. Okay, so it must be on the p orbitals must be on the same plane. So you can see this is a p orbital. Okay, so they are on the same plane. So basically the p orbitals, they are arranged 90 degrees, okay, to the plane. So this is another diagram which show all the 6 p orbital, they are in the planar. Okay, they are in the same plane. So when they're in the same plane, okay, the 6 pi electron, which is from the 3 double bond, that can be distributed evenly, okay, over the 6 carbon atoms of the ring. So because the 6 pi electron, okay, they can, so we say the 6 pi electron that can delocalize. Okay, so they all move around, okay, in the 6 carbon. So as you know, benzene ring, okay, so benzene ring we have 3 pi bond. So each pi bond have 2 electrons. So basically benzene ring we have 6 pi electrons. So the third criteria, completely conjugated. So completely conjugated means that the molecule will have the alternate single and double bonds. So in the benzene, you can see the structure. Okay, I have a double bond, single bond, double bond, single bond, double bond, and a single bond. So they are in the alternate. So this will be, okay. So the other structure, okay, I have a double bond, double bond, and then afterwards, then 3 single bond. So they are not in alternate. So it will, okay. So if not alternate, so they is not considered as completely conjugated. Okay, so the fourth criteria, it must obey the Huckel's rules, okay, which is the Huckel rules is 4n plus 2 pi electron. So the n can tell us how many aromatic ring are there. Okay, the n can tell us the number of aromatic ring. So how to calculate the pi electrons? Okay, so the pi electrons, it will depends on the number of double bond. So for example, for benzene ring, okay, so for benzene ring you have 3 pi bonds, okay, so 3 double bond. So 1 pi bond is equal to 2 electrons. So here we have 6 pi electrons. So we can say 4n plus 2 is equal to 6 pi electrons. So we can find the n. So if the n is not equal to an integer, okay, or not equal to a whole number, it means that that is not a aromatic compound. So for our benzene ring, we will get n is equal to 1. So it means that there will be one benzene ring in the structure. So for this structure, okay, it is cyclic. Okay, cyclobutadiene is cyclic, it's planar, it's also completely conjugated. Okay, so now we are going to try on the Huckel's rule. So you have 2 pi bonds, so you have is equal to 4 pi electrons. So we will apply the rules, see whether it can apply the Huckel's rule. So we will say 4m plus 2 is equal to 4 pi electrons. But the n, okay, the n we calculated is not equal to an integer, so means that the cyclobutadiene cannot consider as an aromatic compound. So we can use a Huckel rule for n plus 2 equal to the pi electrons. So if the n is equal to an integer, so it will be considered as aromatic compound. Okay, so the aromatic compound is also known as a Kekulé structure, okay, because this benzene ring, okay, is proposed by the scientist Kekulé that the carbon are in the hexagon shape. Okay, so that benzene is made of 6 carbon and they are arranged in a hexagon shape. Okay, so this is an expanded structure, and the other one is the skeletal structure of our benzene ring. So the molecular formula is C6H6. So when you see a molecular formula, okay, of the ratio between the carbon and the hydrogen is very low, so we can probably know there is a benzene ring in the compound. So Kekulé also suggested that there is a fast equilibrium interconverts, okay, between the 2 isomers of the benzene ring. So for example, you can see the 3 pi electrons in my benzene ring can delocalize, okay, within the ring to form another isomers. So he suggested we can also draw the benzene ring, okay, by using the with a circle in a hexagon shape, okay, we show that the double bond can be delocalized. So when you draw the benzene ring, you can use this structure or in terms of the ring in a hexagon shape. Thank you for watching my video. I hope this video will help you to identify the aromatic compound based on the 4 criteria. Thank you and see you again.